Hey everybody, this is lesson 8-4, Angles of Elevation and Depression, and this is a pretty easy lesson building on what we've already been working on. So I'm going to try to move through it quickly so that you have plenty of time for homework. I'm not at home working on this, so I don't have the perfect things. I can't get my phone quite as far away from the book as usual, so kind of jump back and forth between following along through my camera and also just reading along in your book. All right, so at the beginning of the page, an angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the line. Let's look down at this diagram for you to understand that as we go. An angle of elevation is an angle formed by a horizontal line, so here's our horizontal line, and a line of sight to a point above the line. So this air traffic controller is looking up to this airplane, and the angle is created by his horizontal line straight in front of him and his line of sight upward. So there's the angle of elevation. In contrast, an angle of depression is formed by a horizontal line, so that's the line in front of the airplane, and a line of sight to a point below the line. So angle 2 is an angle of depression. Now one thing I want you to know or notice is that these two horizontal lines, just by nature of being horizontal, have to be parallel. Therefore, what do you notice happens to angles 1 and 2? They are congruent because they are alternate interior angles. Two parallel lines crossed by a transversal creating alternate interior angles. All right, so let's go ahead and work on solving. Let's look at this picture. This is example 1. You look at the picture while I read the problem. Classify each angle as an angle of elevation or an angle of depression. So let's look at angle 3. Well, angle 3 is made by a horizontal line and a line of sight to a point below the line. So in this case, it's the bird looking down at the person. Therefore, angle 3 would be an angle of depression. Angle 4, which is example 1b, is made by a person and the horizontal line in front of them, the dotted line, and a line of sight up to the bird. Therefore, that is an angle of elevation. All right, I think that that's pretty easy to figure out. Let's look at one more. Let's look at angle 5 and check it out. And here the person has the horizontal line in front of them, but a line of sight down. And so angle 5 is an angle of depression. And one more from, I think that's a tree. Yeah, from the tree, like if there were a bird in the tree looking up at the person, that is an angle of elevation. All right, so now let's do some math with this. You look at the diagram. An air traffic controller at an airport sights a plane at an angle of elevation of 41 degrees. So here's the person, the air traffic controller at the airport. Here's the plane, and the angle of elevation is 41 degrees. Here's the horizontal line, here's the line of sight looking upward. The pilot reports that the plane's altitude is 4,000 feet. So from ground to pilot is 4,000. And then the question is, what is the horizontal distance between the plane and the airport? So the distance from the airport straight across to where the ground is below the plane would be our distance x. Now we're simply going to use our trig functions to solve for this. We have opposite and we have adjacent, and the only angle we have to use, the only acute angle, is angle A, or the 41 degree angle. So we can say, and this is the work that I've done in the past, we can say the tangent of 41 is equal to the opposite over the adjacent, or 4,000 over x. Now, we need to get x alone, so we've got to multiply both sides of the problem by it. So we're going to have x over here, but then to keep it alone, we need to divide by tangent of 41. So we're going to have x is equal to 4,000 divided by tangent 41. And when we do the math on that, we find that our horizontal distance is 4,601. I think what I did there was put square, but I forgot to put feet, so it's feet squared. And hopefully you understood that problem. That's simply, again, building on what we've been doing. Now, our check it out says, suppose the plane's at an altitude of 3,500 feet. I've redrawn it. And the angle of elevation this time is 29 degrees. So here's our air traffic controller. here's our airplane, here's the height of the airplane, here's the horizontal distance between the airport and the plane, and the angle looking up is 29 degrees, or the angle of elevation. So we're simply, again, going to use tangent because we have opposite and adjacent in order to solve for the adjacent. I'm looking to see if I did that math. Yes. So the tangent of 29, come back over here, the tangent of 29 is equal to 3,500 x. Then we're going to multiply both sides by x, divide both sides by tangent 29, and we would say x is equal to 3,500 divided by tangent 29, and we would get 6,314 feet squared. I'm sorry, we don't need squares here. I don't know what I'm thinking. This is just distance. Hopefully y'all caught that in my first mistake. So that actually is just a little tick mark for feet, and that's exactly what this is that I couldn't tell earlier. All right, so just 4,601 feet in example 2. Forgive me for that. All right, now we're gonna look at example 3. Similar problem. You look at the diagram, which is going to be tricky here. Let me see what happens if I turn my camera. See if we can fit it all in. Sorta. Okay. All right, so I'll read the problem. You look at the diagram. A forest ranger in a 90-foot observation tower sees a fire. Here's the observation tower. It's 90 feet high. The angle of depression to the fire is 7 degrees. That's the angle right there. Remember, it's the horizontal line and the line of sight to an object below the line. So it's not within our triangle, it's above our triangle. And here's our forest fire. We want to find the distance from the tower to the fire. Okay, so we don't have an angle to label in here, or we don't have an angle already labeled because the 7 is what I put in. So pretend like that's not there. The only angle we know is our 90-degree angle, but we're going to need another angle. So remember, our two horizontal lines are parallel. Therefore, our angle of depression and our angle of elevation are alternate interior angles, making them congruent. So this is going to be 7 degrees. Now we can use our tangent function to find the distance of x, or the distance of SF. So we're going to say the tangent of 7 degrees is equal to 90 over x. Now look what you got right here. The tangent of 7 is equal to 90 over x. We're going to multiply both sides by x. We're going to divide both sides by tangent 7. The math will be 90 divided by tangent 7, and that solves for the horizontal distance, and that's 733 feet. All right, let me set my pen down and flip the page. So now we are at the top of page 546. This is a very similar problem except for 2 steps. So again, let's let you look at the diagram while I read the problem. Let's see, I'm going to try turning it this way. Again. There we go. Okay. All right, a pilot flying at an altitude of 2.7 kilometers. So here's the pilot. Here's his height or altitude, 2.7 kilometers. Sights 2 control towers directly in front of her. So here's one control tower, and here's the other. Of course, the control towers are not up in the air, but what they mean by directly in front of her is directly ahead. So let's see. The angle of depression to the base of one of the towers is 37. So this is the angle of depression to the farthest away tower. And then the angle of depression for the other one is 58, and that's for the tower that's at point A. So we need to solve for distance y and distance z, and what they want to know is what the difference is between the 2 towers. So they want to know what distance x equals. All right, so let's start with, I'm looking to see which one they started with. Give me just a second. They started with the first one, so let's start here. We are going to realize that our angle of depression and our angle of elevation are congruent. So if this is 50 degrees, then this is also 50 degrees. And we can use our tangent of 58 degrees equals opposite over adjacent. So let's look at what they did. the tangent of 58 degrees equals opposite 2.7 over adjacent, which is y. When we solve for that, y equals 1.6871 kilometers. So that's distance y right here. Now let's solve for distance z. So it's the distance between the pilot and the second or the farthest away control tower. So again, we're going to recognize that our angle of depression and our angle of elevation are congruent or equal because they are alternate interior angles. And we're going to say the tangent of 37 degrees equals the 2.7 over the z. Here we have tangent of 37 equals 2.7 over z. We do the math, and here is the distance for that one. To find the difference between the two, we just subtract 3.5830 minus 1.6871, and here is our answer. All right, I hope that was easy enough for you. I think you'll find that to be not too tricky at all, and I hope your homework goes well. Y'all have a good day.